Hello, guys. So today I want to talk about the Coriolis effect, which is something I recently learned in one of my classes. So I want to start off with this diagram. Suppose you have a disk that rotates on this center and it rotates like this. So I want to ask a question. Would X travel a larger distance or would Y travel a larger distance? Well, if I draw an arrow showing each letter's pathway, it's kind of obvious that Y travels the largest distance, and that's because it's further from the center. Y is further from the center, that's why it travels a larger distance when the disk is rotated. Now suppose the gray disk, this whole disk is the Earth from the top side. So this is the North Pole, and X is like a location near the North Pole, while Y is closer to the equator. So now Y, because of our analogy, would travel a larger distance because it just has a larger distance to go at the same time as X has to travel a smaller distance. So now that's the basis of the Coriolis effect. That as the Earth rotates, every point on the Earth has to rotate a different amount of distance in the same time. And so the points at the equator would move faster than the points near the poles. So if you apply this, so there's several different interesting applications of this, and I want to show you one interesting one. So suppose you have a large pool on the north hemisphere and on the south hemisphere. So, and let's suppose that the water is undisturbed and it's really still. And this thing is a plug. So if we can take it out and the water will start draining away. So let's put some points on these pools. So this is a point, and this is a point, and this is a point. This is a point. So now, if I take this plug away, the water will start draining, and basically, these two things will start moving inwards. But on the northern hemisphere, because this plug is closer to the equator, this one has a larger initial speed that way. So it will keep going that way, while this one is closer to the pole, and therefore it has a smaller speed that way. So let's check out all the arrows. As these dots move closer to the center, this one will start spinning that way, and the upper dot will start spinning that way. Basically, the water will spin counterclockwise. And this is interesting, but if you look at things from the southern hemisphere's point, the same thing. If you take the plug out, the points will start moving inwards, but this time the lower dot is closer to the poles, so it will start moving. It will move slower than the upper dot. So this would be the motion of the two dots, and the water will actually move clockwise. And this is really interesting because if you think about it, when I was your age, I never figured out that the spin of water on the two hemispheres will ever be different. But the Coriolis effects proves that these bodies of water will spin in opposite directions. Now you have to pay attention to the experiment. There's a lot of videos on YouTube and a lot of experiments in the real world that don't go through the precautions we had. So basically, the pool has to have no external forces on it, meaning that there can't be any movement. There's a lot of kind of fake videos that try to prove the Coriolis effects without really making the water still or placing the pools on the north or south hemispheres. So you have to be really careful. And lastly, this is a good video to watch if you want to see a real life example of the experiment I just outlined. Thank you.